Alright, so today we are talking about linear measure, how we can add segments together to equal a larger segment. So first we can talk about what a line segment is. And a line segment is a line that is defined by two endpoints. This means it can be measured because we have two endpoints. And if segments are congruent, we call that, congruent segments are when we have two more segments that have the exact same measurement. In geometry, we don't say segments are equal or angles are equal. We say they're congruent. Because equal implies that segments are both exactly the same, whereas congruent says we know they're different segments, but they have the exact same measurements. It's a slight distinction, but it is important enough to recognize congruence versus equal and what that means in geometry. Now our line segment addition. So we have point C, it's between points A and B. So if this is true, that means I can add AC and CB together equal the whole line AB. This kind of makes sense, because if AC was 3, and BC was 7, we would add 3 plus 7 to get 10 for the entire line. So we're going to use that concept to solve different problems using algebra. So for example, we're told that AB is 30, AC is 17, and BC is X. And given the information, they tell us that C is between A and B. So this tells me that AB is the biggest line, AC and BC must add to be it. So AC plus BC equals the AB. This will always be true for all the problems involving this setup. Anytime you have different points, you have like D, E, and F, or Q, R, and S, whatever it is, whichever the line actually is, so it tells us some point is between two other points. The 2 points that are on the ends, that's the longest line, that's the one by itself. The other two will have to add to it. So this is a very straightforward problem. We subtract 17 from both sides. The next is 13. Now they also want us to find the unknown segment. Well, in this case, BC is the only unknown segment, and BC happens to be X, so BC is just simply 13. Had it been like 2X, we'd have to do 2 times 13 to find the BC. Pretty much, if they want us to find unknown segments, we just plug back in directly into the problem. So same setup. So we know that, again, AB is by itself. AC and BC must add to be it. So 2x minus 4 plus 7 equals 19. So when I combine the negative 4 and the 7, I get 2x plus 3 equals 19. Subtract 3 from both sides. 2x equals 16. Divide both sides by 2. X equals 8. Halfway done. Now we need to find AC's length. So AC we do 2 times 8 minus 4, which is 16 minus 4, which is 12. So you solve your basic linear equation, and you plug back in to find the missing side length. Again, the whole key is using the concepts that the biggest length is the one that's all by itself, the 2 smaller ones add together, and based off what they tell us in the given statement, it tells us which side's the biggest and which ones are the smaller sides. Exact same setup, so I'll do it the exact same way. AC plus BC is equal to AB. So a slightly more complex algebra problem. First, you want to combine like terms on this side. So we have 2x plus 41 equals 8x plus 5. So let's solve for x. So I'm going to move the 2x over to the right by subtracting it. So 41 equals 6x plus 5. We'll subtract the 5 to get the x all by itself. So 36 is 6x, divided by 6, and x is going to be 6. Again, we're solving an algebra equation at this point, something you should be very comfortable with from Algebra 1. So now we need to plug it back in to get AB and AC. So AB is 8 times 6 plus 5, which is 48 plus 5, which means AB is 53. And then for AC, it's 2 times 6 minus 3, which is 12 minus 3, which means AC is 9. Okay, one more together. The reason why is because this one's a slightly different kind of problem. This is not 2 times x, this is 2 to the x power. This is an exponential equation. Setup is still the same, 12 plus 2 to the x equals 28. 2 smaller pieces add to be the larger. That setup has not changed no matter how the problem looks. Now, To solve an exponential, we still need to isolate the exponential, exact same as we solve linear. So we subtract the 12 from both sides to isolate the 2 to the x. So 2 to the x equals 16. And now we need to ask ourselves, okay, can I rewrite 16 as 2 raised to some power? 2 raised to what number is 16? Well, if I do 2 to the 4th power, I get 16. So I can rewrite 16 as 2 to the 4th. So now that I have two exponential problems, since the bases are both exactly the same, that means the exponents must be equal. So x equals 4. My only unknown is BC. Plug 4 back in. We get BC to be 16. So review your notes on exponential equations. If you are not quite familiar with those, we will review those throughout the year, but make sure you are comfortable with having to solve them. We're not going to reteach that to you. Alright, so on your own, go ahead and solve these two linear measure problems. Set up the correct equations, and solve for x. So go ahead and pause the video while you work that one out. Alright, so the first one, x should equal 4, meaning AC is 21 and BC is 18. The second one, x should be 3, meaning AC is 27. That was an exponential equation, so make sure you solve it the correct way. Alright, so that's it for the next section, talking about linear measure. We'll move on to angles and other topics in a little bit. See you next time.